Okay, in this module, we're going to continue where we left off, and where we left off was infinity. We talked about two different types, but I really focused on that unbounded type of infinity, how to keep the numbers from keep expanding in either direction. And we talked about using Bayesian reasoning or Bayesian priors to form constraints that will put boundaries around infinity. And when we do that, I use this example of creating this three-dimensional space. And where we left off was that now this is three-dimensional because in this example I only have three variables for so that we can more easily visualize it. And so we left off with what we need to do is to form this. This is our solution space, and then explore it. But the exploration has a problem in that we have to deal with this other type of infinity. So continuous infinity. So how do we deal with that? If we're going to explore this space, we need some sort of strategy. And in order to do that, the strategy that we're going to do is to form steps, essentially making taking the infinite density in this space and essentially forming like small blocks within this cube, within this three-dimensional space, and using those to make it easier to explore. And we're going to talk about what I mean by exploring. And that's going to be a strategy for saying, okay, if we've got a certain number of possibilities, then we can sort of catalog them and compare them. So how do we do that? So if we're going to deal with continuous infinity, here's essentially the problem that we're working with. Let me switch to a different screen. So let's say we have these three adjustment factors, and we decide that we're going to deal with that continuous infinity by saying I'm only going to allow 5 choices. So instead of an infinite density, I'm going to only allow 5 choices for each of the 3 variables. And what that allows me to do is essentially take this object and break it into those 125 blocks. So if I've got 3 adjustments and 5 possibilities per each, then what I'm doing is I'm essentially breaking this up into 125 pieces, and I can analyze each piece and essentially look for is this piece here in this corner the best explanation for my data set, for my comps and the differences that I'm seeing, and the price differential between each sale. And so by doing that, we're going to be able to manage this space that was of infinite density, and now I'm going to just to deal with a really much smaller number. Now, this does get a little problematic. So let's look again. So if we only have 3 adjustment factors and 5 possibilities each, we have 125. That's still quite a few possibilities to work with. But let's look at what happens if we have 5 adjustment factors. So 5 differences, 5 variables that we're having to deal with in our comparable data set. Well, now we're up to 3,125 possibilities. That's a much, those little blocks are getting much smaller. Well, what if we have 7 adjustment factors and we still only have 5 possibilities that we're using to deal with that continuous infinity? Then we have 78,125 possibilities. So things seem to be getting out of hand. How do I deal with that? And so that is where we need to then begin to talk about the strategy for for searching and cataloging and comparing these individual blocks. So if we're, again, three-dimensional space is easy to visualize. If we're talking about 7 adjustment factors and 5 possibilities for each, we can't even really easily visualize what that looks like. Although I will we'll try to show a visual next time to help us to see what that looks like when we actually put some numbers around it in an example. But essentially what we've been able to do now is we've used our prior knowledge and our prior experiences to form a solution space that will operate in ways that we've defined, which are ways that we're saying we have observed the market to behave. And we're using that to form a solution space where we believe market value exists somewhere in there. There's a combination of possibilities of each adjustment factor that's going to be the best explanation for my comparable data set and all the differences that I've noticed there. So how do we identify where that is? And keep in mind, we're still dealing with these interdependent factors. So there could be more than one solution that that essentially seems like it might be in the same ballpark of being a good explanation. So how can we identify those and not just make that deterministic solution of like, okay, I just want the one answer. That one answer isn't really going to be as helpful as we've talked about. What we want to be able to do is, okay, we've identified the solution space, but now if I have these 125 blocks in here, what am I going to notice about which ones seem to be among the best explanations? What we're going to find is that those blocks that are the best explanation are going to clump together in a particular area. What we'll discover is that as we explore that space in the way that I'm going to begin to describe next time, what we're going to find is that, you know what, this part of the solution space, there's no real possibility that value exists here, because none of these explanations in this region are really good explanations for our data set and the differences that we've noticed. But maybe this region right here is, this is where all of the best explanations for our data set and the differences that we've noticed, they sort of clump together. And that's going to be really helpful, because it's actually going to help us to correct ourselves if we have defined a solution space and we didn't do a particularly good job. It happens. So maybe there's just a lot of unknowns in a particular market, and we're not sure about, maybe this one adjustment factor I've got a real good handle on, this one I've got a real good handle on, this one not so much. I'm not feeling very confident about how I've defined my solution space there. The strategy that we are discussing will actually show that when all the best solutions tend to clump at the edge of the solution space, then it tells you, well, I might need to consider how I have defined my solution space. Maybe this shape isn't really the shape of my market. I thought it was, but if we're talking about a cubic object like this, maybe it's awfully skinny right here. I think I may have defined this a little too narrowly. Maybe the solution space I should have explored was a little bit wider. So that is going to be sort of a visual that will help us to understand how we're actually going to solve this problem.